Okay. Hey, anybody? Sorry for the delay. Uh, Shall I start? Can you hear me? And okay, thank you. Uh, I think it is better to maintain a separate book for circular motion and rotational motion today. Today now we are going to start with circular motion. Therefore, note is given. Therefore, need to write much not today. But there are some parts to be discussed uh, in your notebook. Therefore, I think 120 pages book is enough. පොඩි පොතක් ඇති 120 pages ඇති. Because this is a separate lesson. This is a රකව use කමන්න කමන්න ප්‍රශ්න නැහැ. මොකක් හරි separate එකක් දාලා එහෙම use කරලා එහෙම ප්‍රශ්න නැහැ. මොකද මම කියන්නේ මොකක් හරි කමන්න කොහොම හරි කරලා separate තියාගන්න. හරි. Okay. Now, today we are going to start angular motion lessons. Angular motion. Okay, previously we have discussed about linear motion. In linear motion, the position of the object changes linearly with time. In angular motion, the position of the object moves actually in a circular path, or it's an angular path. So such kind of motions are called angular motion. Here, the position change is not in a linear path. It's not in a linear path. It is in a some kind of circular path. So such kind of motions are called angular motion. So angular motion can be divided into two main segments. One is circular motion. Other one is rotational motion. Circular motion means it is a moving of an object around a certain point, around a circular path, and actually, if any object moves in a circular path, we can take it as a rotation. It is a rotation. Okay. Actually, if any object moves in a circular path, we call it as a rotation. So, for every rotation, there should be a certain axis. Any object should rotate around that axis. In circular motion, the axis of rotation lies outside to the object. That means it is something like this. So suppose this is the axis of rotation. Then if any object moves around this kind of circular path, whose axis lies outside the object, uh, is called a circular motion. So if we consider about the rotation of the earth, about the sun is a circular motion. Actually, the path is mostly similar to a ellipse puthe, but we can assume that is a circular path, circular motion. Okay. Then motion of the moon about the earth, it is approximately circular motion. So if we uh, attach a stone to a string, and if we rotate that string, then the motion of this stone is a circular motion. So if it is a circular motion, the object moves in a circular path and the axis of rotation lies outside the object. Then what would be the rotational motion be? Rotational motion. The rotational motion means it is also a rotation. But the axis of rotation, lies through the object. The axis of rotation lies through the object. So if there is a rotation above this axis, we call it is a rotational motion. Okay. So that is the difference between rotational motion and a circular motion. Yeah. So if we consider about the rotation of a fan, rotation of a fan blades are rotating about an axis which goes through its own body. No? So what are the examples? What are the examples for rotational motion? Can anyone give me example? Here. So circular motion means moving an object about a circular path and the axis of rotation lies outside to the object. Rotational motion means it is also a rotation and the axis of rotation lies through the object. Okay. Then, can you give me some example for rotational motion? Yes, just put all correct. Bicycle wheel, not only bicycle wheel, all the wheels of the vehicles, they are rotating its about its own axis, bicycle wheels or wheels of vehicles, then what else? How hmm? Yes, it's been a book on a finger. Oh, I got that. And we have begun one correct in theory. Yes, rotating a fan, Puti, yes, rotating a fan. Earth turning around its own axis, yes. Rotation of the earth, rotation of the earth. All are rotational motions, Puti, all are rotational motion. But you have to remember this thing. Suppose now this is a disk, Puti. Now this rotate about this axis. Now this rotates about this axis. Now it is very clear if you consider about this kind of point, if you consider about this kind of point, and if I draw a plan view, plan view if I draw a plan view, now it is something like this. So this is the axis of rotation. Now this object rotates about this axis. And if you consider about this kind of point, if you consider this kind of point, it is very clear that point is moving in a circular path, in a circular motion. If you consider about this kind of point, that also moving in a circular path. If you consider about this kind of point, that point also moving in a circular path. Therefore, if we consider about a rotational motion consists of number of circular motions, for the number of circular motion, because uh, the particles of this object moves in a circular path. Therefore, a rotational motion means it is a combination of circular motion. Is that clear? If it is clear, please raise the negative on to sun. Okay. Therefore, angular motion can be divided into two major categories: circular motion and rotational motion. Circular motion is something like this. Moving of an object in a circular path and its axis lies outside the object. This is the axis of rotation. Uh, okay. You can do this one. Well, Okay. Now, if you consider about angular motions, Pute, as we discussed in linear motion, actually, when we are going to describe a linear motion, we have to have define some physical quantities. Otherwise, we cannot describe a linear motion. Pute. We have to have some physical quantities, uh, that can be used to describe a linear motion. So in such cases, we use we use physical quantities like displacement, distance, velocity, speed, acceleration. So such kind of physical quantities were defined to describe a linear motion. Likewise, we have to define some angular quantities to define angular motion. Now, we are going to describe those angular quantities. Put it. Then our next topic is angular quantities. No need to write them. It is in the book. Angular quantities. Okay. Suppose now this is a circular path. Suppose there is a object at this position at t equals 0. Then this object moves along this circular path to this location, within simple theta. Now, it is very clear, initially this object was at this position. Now this object is at this position. Therefore, if we consider about the angular change of position, we can define the position change. We can define the position change of this object by means of an angle. බලන්න පුතේ. Look at this. So if we say there's a displacement about theta angle. There's a displacement about theta angle into the anti-clockwise direction. Then we can locate the final position of this object. Therefore, using an angle, we can illustrate a position change with it. Therefore, if there is angular motion, the change in position can be represented by means of the angle subtended at the center of the circle. Okay. So this angle is called the angular displacement. Here, the displacement is represented by this angle. We can say now this object has an angular displacement of theta into the anti-clockwise direction. If we represent the displacement like that, then we can locate the final position of the object. Okay, therefore, this is called angular displacement. For the angular displacement is measured by, this is an angle, but this is an angle. Therefore, angular displacement is measured by radian because the SI unit of angle, is radian. Therefore, unit of angular displacement is radian, the angular displacement. This is angular displacement. Therefore, unit of angular displacement is radian. Therefore, angular displacement is the angle subtended at the center of the circle during a circular motion. Okay. Did you get my point? පැහැදිලිද? දැන් ඔයගොල්ලන්ට මතක තියෙන ඕන දේවල් ගොඩක් තියෙනවා radian එකත් එක්ක මතක තියෙන ඕන ගොඩක් දේවල් තියෙනවා. You know how to convert radian into degree and how to convert degree into radian. You know that thing. Okay, how to convert radian into degree? Sorry, degree into radian. කොහොමද අපි ඒක convert කරන්නේ? You have to remember that conversion පුතේ. You know 2π radian is equal 360 degree. 360 degree. 2π radian is equal 360 degree. Therefore, yes, 5 Therefore, one radian is equal 180 over 5 degree, or other side 1 degree is equal 5 over 180 radian. This is the conversion. This is the conversion of radian to degree. Pertanyaan muncul saya tidak dengan pasti malu. So if it is a circular motion, you know this object moves along this path. Therefore, if it is a circular motion, not only the angular part, but also there is a translational part. No, actually this object, although this object moves in a circular path, actually the position of this object has been changed, no? Therefore, there is a translational part also, no? There's a translational part also. Has a translational part. Therefore, if we consider about the circular motion, the position of the object change with the time. Therefore, with respect to the earth, the position of the object change with the time. Therefore, not only angular part, but also there's a translational part. The only difference is this translational motion is not a linear motion. The path is a circular path. Is that clear? If you get that one, please raise the hand. That means if this object moves a full circle, it will travel a distance of 2 pi r. 2 pi r, which is the circumference of the circle. Therefore, distance travel is equal to the circumference of the circle. Circumference of the circle. Therefore, if we consider about a circular motion, there is a angular part as well as a circular part, as well as translational part. Therefore, a circular motion have an angular part as well as a translational part, as well as a translational part. But the thing is that translational motion is not a linear motion. Therefore, normally we can represent the translational quantities as scalars, distance, speed, likewise. ඒ නිසා මේ translational part එක අපි linear motion එකක් නෙවෙයි. ඒ නිසා අපිට ගොඩක් වෙලාවට අපිට කතා කරන්න වෙන්නේ distance එහෙම නැත්නම් speed ඒ වගේ scalar quantities එක්ක. Right? But remember, there is a translational part. And okay. ඒක අපි දාගමු මේක note එකේ නැහැ මම දුන්නේ. ඒක දාගමු. A circular motion consists of both angular part and a translational part. Translational part. When there's a full rotation, the object will travel. When there's a full rotation, the object will travel a distance of 2 phi r. A distance of 2 phi r. Okay. So therefore, when we are describing a circular motion, we have to discuss both translational part as well as the angular part of it, because it has both. Therefore, we have to consider both angular part as well as the translational part. So we need to determine the relationship between the angular part and the translational part. The angular part and the translational part. So you know, now, so if this is the angular displacement, so this is the angular displacement. So this is the angular part. So when the ball moves from here to here, the translational distance traveled by that ball is equal to this arc length, Therefore, this is the translational distance, translational position change. This is a translational position change. So this is the angular position change. And actually, this is the position change. This is the position change by means of angular displacement. This is the position change by means of translational distance. Therefore, there is a one position change. Actually, there is a one position change. We can represent that position change as an angular part as well as a translational part. Did you get my point? Pathirage? Hmm? ඒක තේරුණා සුස්සන්? Okay. Thank you. Okay. So if we consider about this displacement, if we consider about this displacement is S and the radius of circle is R, then we know the relationship between S and R and theta is equal R theta. S equal R theta. We know this thing. We know how to determine the arc length. You know this is an arc, this is an arc. So if this length is S, if this length is S, the arc length is equal theta into R is equal R theta. Therefore, S means the translational position change is equal R into angular displacement. Angular displacement. Therefore, this is the translational position change. This is the angular displacement or angular position change. මේක අවශ්‍ය දේවල් තියෙනවා note එක දාගන්න. මේක අවශ්‍ය දේවල් ඔයගොල්ලන්ට note එක දාගන්න. මම ඔක්කොම ටික note එක දැම්මේ නැහැ අවශ්‍ය දේවල් note එක දාගන්න. Okay. Okay. Now, if we consider about angular displacement is measured by radian. And you know, angular displacement. Angular displacement means angle. Angular displacement means it is an angle. You know, angle has no dimensions. Angle has no dimension. Therefore, angular displacement has no dimension. Angular displacement has no dimension. Therefore, dimension of angular displacement, we can write it as 1 or it has no dimension. It has no dimension. And ඒක දාලා තියෙන්නේ ඊළඟ කරදරේ තමයි ලස්සනව කතන්දරේ. Whether the angular displacement is a vector or not. Vector or not. That is a problem. That's a problem. Actually, normal condition, we consider it as a vector. It has a vector, but the thing is, there's a problem. There's a problem is angle. So if it is a vector, it should comply with all the properties of vectors. Otherwise, we cannot consider it as a vector. Therefore, if it is a vector, it should actually satisfy all the requirements, all the characteristic of vector. But there's a one problem. There's a one problem, that is this one. You know, if it is a vector, vector addition, the vector addition actually, if we consider about A plus B and B plus C, both are same. Both are same. Both are same. We call it as commutative law. And both are same. A plus B and B plus C, both are same. Therefore, if it is a vector, this vector should satisfy this law. A plus B should be equal B plus C if it is a vector. But angular displacement is not satisfy this law. But all the other things are satisfied with the characteristic of vectors. This is the only contradiction point with the properties of the vector. Therefore, if we consider about, if normally in normal condition, we can say it has some properties of vector, but there's a contradiction. හරිද? ඒ නිසා මෙතන contradiction එකක් තියෙනවා. මේක vector එකක්. ඒ කියන්නේ vector properties තිබ්බ වුණාට මෙන්න මේ කියන property එක ඔකේ නැහැ. ඕකත් එක්ක පොන්චි කතන්දරයක් තියෙනවා. ඕගොල්ලෝ බලන්න සමහර තැන්වලදී ඕක ප්‍රජපත්තරම කියලා ඇති. ඒකට හේතුව මෙන්න මේක. ඒ නිසා අපි physics වගේ ගත්තොත් ඒක සමහර වෙලාවට ඉතින් අපිට මේක vector එකක් කියලා හිතන්න පුළුවන්. නමුත් ඒක ගොඩක් වෙලාවට මම හිතන්නේ ඔය question එකක් අහයි කියලා ඔයගොල්ලන්ගේ. මොකද ඒකේ contradictions කතන්දර ගොඩක් තියෙනවා. Okay. Therefore, there's a contradiction between the properties of vectors and properties of angular displacement. බලන්න මේක මොකද්ද මෙන්න මේ කියන කතන්දරේ කියලා. හරි. Look at this one. බලන්න මෙහෙම දැන් තියෙනවා. බලන්න. පුතේ, now this object. හිතන්න මෙහෙම දැන්. Now this object is rotating. මේක rotate වෙනවා. Look at this one. Now this object at this position, this is the initial position. Now this object turns 90 degree to front direction, 90 degree front direction, and 90 degree to this way. Now the position is like this, no? One, look at this one. Now, so this is the initial position. I'm here. When initial position, this is the initial position. Now 90 degree to this side. 90 degree to this side and 90 degree to right hand side. 90 degree. Now 90 degree to back side. 90 degree to back side. And this is the initial position. හැමෝම බලාගන්න පොඩ්ඩක් මේ this is මම මේක පොඩ්ඩක් ලේසි වෙන කතා කරන්න. So this is the initial position. This is the initial position. First, I will add 90 degree to backward direction, and then I will add another 90 degree to right hand side. 90 degree to backward direction, 90 degree to right hand side. So if we rotate 90 degree to backward direction and 90 degree to right hand side, now this is the final position of this object. This is the final position of the object. 90 degree to backward direction and 90 degree to right hand side. Now, shall we do this one in backward one, in reverse direction, in reverse one. But මුලින්ම backward right hand, backward right hand. Now I'm going to do first right hand direction, 90 degree to right hand, then 90 degree to backward. Now what is the position? කලින් මෙතන මෙහෙම විදිහේ position එක 90 degree to backward, 90 degree to right hand. දැන් මම මොකද කරේ? ඔක අනිත් පැත්ත. 90 degree to right hand, backward. බලන්න position දෙක එකමද? නෑ. Position දෙක එකම නෑ දෙකක්. Therefore, there are two different positions. Therefore, if we add 90 degree to backward plus 90 degree to right hand side, it will give one position. If we change the order, that means if we add 90 degree to right hand side first, then 90 degree to backward direction, then if we change the order, the position of the object changes. That means A plus B is not equal B plus A in angular displacement. Did you get my point? If you get that one, please raise your hand. If we consider about angular displacement, we cannot change the order when there's addition. When there's addition, we cannot change the order. If we change the order, final output can be changed. Okay. This is about angular displacement. Then the second part is angular velocity. As we define in linear velocity, angular velocity is equal to the rate of change in angular displacement. We represent it as So if you see omega, omega is the symbol. Therefore, omega means rate of change in angular displacement. Rate of change in angular displacement. Therefore, we can write it as d over dt theta. This is the rate of angular displacement, and this is the mathematical representation. So this one is equal change in angular displacement over time taken. Over time taken. Over time taken. Therefore, this is very much this definition is exactly equivalent to the definition of linear velocity. Rate of change in angular displacement. Rate of change in angular displacement. So if we consider the unit is equal, omega is equal rate of change in angular displacement over time taken. So angular displacement is measured by radian, time taken is measured by seconds. Therefore, unit of angular displacement, unit of angular velocity is equal radian per second. Radian per second. Now tell me, what is the dimensional formula of angular displacement? What is the dimensional formula of angular displacement? Here. I need responses from everyone. Then we will need one color. Yes, very good. So it is equal to t minus 1. Yeah? T minus 1 because radian is an angle. It has no dimension. Therefore, angular displacement. Sorry, dimension of angular velocity is t minus 1. T minus 1. T minus 1. All right. Then, how to determine the direction? The angular displacement is a velocity. This is a vector. Angular displacement is a vector. Angular velocity. Angular velocity is a vector. This is a vector. This is a vector. Then how to determine the direction of angular velocity? How to determine the direction of angular velocity? In that case, we can use the same method which is utilized in moment. So when we are determining the direction of moment, we use the right hand rule, right hand corkscrew rule. The same thing can be used. So in that case, you have to put your four fingers into the direction of motion. If you put your four fingers into the direction of motion, the thumb gives the direction of angular velocity. And normally we can say it is into the clockwise direction. No, it is into the anti-clockwise direction. But that is not the exact direction. If you want to find the exact direction, you need to apply right hand corkscrew rule. How to apply? You have to put your four fingers into the direction of rotation. Then your thumb will give the direction of angular velocity. So that means if there is a anti-clockwise rotation, the direction is out of the plane. The direction is out of the plane. So if there is a clockwise rotation, so if there's a clockwise rotation, now it is very clear if you put your four fingers into the direction of rotation, the thumb is directed into the plane. Therefore, if there's a clockwise rotation, the direction of the angular velocity is into the plane, into the plane, into the plane. Direction, omega direction. Okay. අනිත් ඒවා දාලා තියෙනවා direction එක ඕන mark කරගන්න. If you want to mark the direction, if you want to mark these two figures, you can mark them. Note එකේම දාගන්න පුළුවන් තුන. Therefore, anti-clockwise rotation gives a direction into the out of the plane. Clockwise rotation gives the direction into the plane. Actually, I have marked this one as into the plane and out of the plane because this object rotates on this plane. Okay. It is rotate on this plane, but this is a three-dimensional thing. Rotation means it is a three-dimensional thing. And එතකොට මේක three-dimensional thing නිසා rotation එකක් ඕනියතකට වෙන්න පුළුවන්. හරිද? දැන් මම මේ කතා කරේ මේ board එකේ plane එකේ තියෙන rotations විතරයි. ඒක නිසා තමයි into the plane and out of the plane නාන්නේ. board එකේ rotation එකේ board එකේ plane එකේ නැති rotations තියෙන්න පුළුවන් උත්තර. මෙහෙම plane එකේ නැති rotations තියෙන්න පුළුවන්. As an example, if you consider about this kind of rotation. So if this wheel rotates in this side, then what is the direction of angular velocity? What is the direction of angular velocity? What is the direction of angular velocity? So the subject rotates into this side. Then what is the direction of angular velocity? Oh, ready? Others? I need answers from everyone. Yes. Yeah. That is into the upward direction, no? If you put your four fingers into the direction of rotation, the thumb is directed into the upward direction. Therefore, here, direction of omega is in upward direction. Is in upward direction. Did you get my point? ඒක නෑ හැබැයි මේක දාලා තියෙනවා. හරි. Then you know, as I mentioned you earlier, there is a angular part as well as a tangential part. Therefore, as we described earlier, there is a relationship between angular displacement and translational distance. Likewise, now we can determine the relationship between angular velocity and the translational speed. Translational speed. And, look at this one. This is t equals 0. Okay. Now it is very clear angular displacement. Angular displacement of this object is theta. Angular displacement is theta. And you know angular velocity. Angular velocity. How do you determine angular velocity? Angular velocity is equal theta over time. Theta over time. And, and, and you know, S means translational displacement. So translational distance. Translational distance is equal R theta. Is equal R theta. So if you divide both side by time, that means actually you had to derivate both sides with respect to time. So instead of derivation, I will use the term dividing both sides by time. If you divide both sides by time, Putri, you will have this kind of relationship. What is this? It is the distance over time. It is the distance over time. Distance over time, Putri, that means the speed V is equal R here on the latitude. R omega. Put it here V equal R omega. V means translational speed. R means radius. Omega means 10 angular velocity. Angular velocity. Okay, I will explain. You know, angular velocity is defined angular displacement over time. Angular displacement over time, angular velocity is equal angular displacement over time. And you know this relationship is equal R theta. So if we divide both sides by time, S over time R into theta over time. You know, theta over time means angular velocity omega here R. S means that is the distance traveled by this object. S means distance traveled by this object over time taken. Distance over time taken means it is speed, the speed v. Put if we consider about this speed, look at this one. So if we consider The velocity of this object, the velocity, translational velocity of the object, the translational velocity, the moving direction of this object always is into the direction of tangent. I mean, tangent if this object is at this position, the moving direction is always into the direction of tangent. The direction of tangent. මේ මෙතන නම් මොකද වෙන්නේ? මෙහා යන්නේ මේ පැත්තට. හැම වෙලෙම ඒක අපි දන්නවා. ඒක අපි දන්නවා අපි මේ linear motions කතා කරා. How to determine the direction of direction of moving? How to determine the direction of moving? You have to draw a tangent to the trajectory. You have to draw a tangent to the trajectory. That is represent the direction of the object, the direction of motion. That is the way of determine the direction of motion. You can remember the projectiles. The projectiles will be. So you have to draw a tangent to the trajectory. If you draw tangent to the trajectory, gives the velocity at that point. The velocity at that point. Therefore, the velocity at that point is directed towards the tangent. The velocity at that point is directed towards the tangent. Did you get my point at the end of? Okay. The direction of velocity. The direction of velocity always into the direction of translational velocity. Direction of translational velocity is always directed towards the tangent. Towards the tangent. And okay. Now look at this one. Now look at this one. Suppose if we take very small angle, I'm gonna put angle actually. If you consider very small angle delta theta, then this is almost like this. This is almost like this. බොහෝ පොඩි ඇන්ගල් එකක් ගත්තොත් මේ බලන්න. බොහෝ පොඩි ඇන්ගල් එකක් ගත්තොත් මම ගන්න මේක බොහෝ පොඩි ඇන්ගල් එකක්. If we consider very small angle, very small angular sphere, we can consider this path. We can consider this path as a linear path. Like, you know, if we consider about very small angle, if we consider about very small angle, this path can be considered as a linear path. If this is a linear path, definitely this v velocity we will become the velocity v can speed velocity velocity. Therefore v equal r omega equation. V equal r omega equation also gives the velocity at a certain point. A velocity at a certain point. මේ equation එකේ පුතේ මෙතන තියෙන velocity එක represent කරනවා. බලමු කොහොමද වෙන්නේ කියලා. බලන්න. Look at this one. Suppose very small angle. Okay. If we consider about this kind of scenario, if this is very small angle, if this is very small angle, මේ අතර මේ derivation නැති නිසා මේ දඟලන නැගිලිල්ලක් මේක velocity කියාගෙන නොදී අතර උතේ මේක derivation අපි දන්නවනේ මේ derivation part එක දන්නවනේ ඇත්තටම උතරින් එන්නේ අර instantaneous velocity එක. නැත්නම් ඒක මොහොතක velocity එක එන්නේ. තාම ඉතින් බයෝ කරන කට්ටියට derivations කියන්නේ බෑ. ඒක නිසා තමයි මම මේ පුංචි පොඩි ඒක පාවිච්චි කරන්නේ මේ අපිට derivation එකක් කියලා කියන්නේ පුතේ ඇත්තටම බොහොම පොඩි variation එකකදී මොකද්ද ඒ variation එක rate එක කියලා බලන එක තමයි එතන වෙන්නේ ඇත්තටම. දැන් මේක ඕගොල්ලන්ට අපිට mathematical part එක කියන්නේ නැහැ. හැබැයි final output එක කියන්නේ නේද? final output එකේදී කොහොමද වෙන්නේ කියලා තමයි මම explain කරන්නේ. හරිද? බලන්න පුතේ. So if you consider one very small change in displacement within very short time period. පුතේ හිතන්න මෙතන t equal 0 here t equal delta t කියලා ගන්නවා. Delta t. Therefore, time taken is delta t. The angle displaced is delta theta. So here, from here to here, it is very clear. If this angle is very small angle, then we can consider this one as a linear portion. We can consider this one as a linear portion. Therefore, we can take this V as the velocity at this position. Velocity at this position. මෙතනදී velocity. ඒකට මෙතනදී velocity නෙවෙයි. මෙතනදී මේ මොහොතේදී මෙතනදී velocity. So this is the velocity at this position. So we can take this one as the velocity at this position. Therefore, you know this length. I can take this length as delta S. Very small displacement. Therefore, delta S is equal to R delta theta with R into delta theta. So if you divide this equation by time, delta S over delta T is equal R delta theta over delta T. Okay. අපි මෙන්න මෙතනද ගන්නේ මොකද්ද? delta T කියන එක ගොඩාක් පොඩි වුණා. ඒ කියන්නේ මේක 0 කරා යනකොට මෙයාගේ රේෂියෝ එක ගන්න. 0 කරා යනකොට මෙයාගේ රේෂියෝ එක තමයි අපි කියන්නේ derivation එක කියලා. හරි. ඒක ඕනේ. Okay, so if we consider about this ratio, you know this angle is very small angle. Therefore, this length can be considered as very small length. If it is a very small length, I can consider this part as a linear part. Did you get my point? මේක තේරුණා තුෂ්ණ? මේක ගොඩාක් small වුණොත් ඒක linear part එකකදී හිතන්න පුළුවන්. මේක තේරුණා තුෂ්ණ? මේක assumption එකක් නේ. This is an assumption. මේක මැච් කරන කට්ටිය තේරෙනවා ඇති මට බයෝ කරන කට්ටිය තමයි අවශ්‍ය. I need response from bio student. Did you get my point? එක තේරෙනවද පුතේ? තේරෙනවද? සුපුරුම තේරෙනවද? සසඳු? Did you get my point? Clear? Yeah. So if we consider about this one, if we consider this angle as if we consider this angle as a very small angle, then this part can be considered as a linear part. Linear part line segment so we can consider this one as a velocity instead of speed. Instead of speed, I can consider this one as a velocity from here to here. And therefore, here delta S over delta T. Delta S over delta T means delta S means it is the displacement from here to here. If we consider what this one is A, here B, delta S means that is the displacement from A to B. Displacement from A to B. Delta T means time taken. Here the displacement from A to B. Delta T means time taken. Time taken. Here angular displacement. Displacement over time can be considered as the velocity. But that velocity is particular to this point because A and B are very, very close to each other. Very, very close to each other. If the delta theta is very close to 0, A and B are very, very close each other. They are very, very close to each other. Therefore, now this is the velocity, Pute. But this velocity is the velocity at that point only. At that point only. Therefore, this is the velocity. This is the velocity here omega. Pute, this is the velocity at point A. Point A වල තියෙන exact velocity. Therefore, this is the velocity at point A. So you know the velocity, put a velocity of the object. The velocity of the object, sorry, the direction of the velocity. The direction of the velocity is always into the tangential direction. If we consider about the velocity at a particular point, its direction is always into the tangential direction. A and B are overlap with A and when theta is equal to zero means when theta goes to zero, B goes to A, that means A and B are, we can consider they are same point put. And derivation and therefore we can consider it as a single point. It has a velocity at the single point. Therefore, we call this velocity as tangential velocity. Because the direction of this velocity, is always into the direction of the tangent. It always into the direction of the tangent at the particular point. It's always into the direction of tangent at the particular point. Did you get my point? If you get my point, please raise the hand. I need responses from everyone. But I won't give a responding to Okay, thank you. Okay. If you want to make a whole note, make a note that topic tangential velocity. Tangential velocity Okay, Buddy. After completion of this one, please do the two questions. Please do the two questions. In page number 6, there are two questions. Please do the Okay, okay, Mute. In this question, the figure is not given. Figure is not given. Therefore, you have to write the figure. You have to draw the figure. You have to draw the figure. Figure is something like this. So here, 15-meter long rod. Now it is rotating about this point, Pute. Now it is rotating about this point. Okay. Now this object rotating is rotating about this point. Now here this length is 15 meter. You need to determine the translational velocity. Translational velocity of an object which is placed 5 meter away from the center, 10 meter away from the center, and 15 meter away from the center. Okay. So you need to determine the translational velocity of A, B, and C object. What is the translational velocity of object A, point A? What is translational velocity of point A? Check again. VA. Yeah, but VA. What is the value of VA? What is the value of VA? 50. How did you determine the angular velocity of A, Putri? Angular velocity of A. Huh? Now this rod rotates at an angular velocity of 10 radian per second. 10 radian per second. So suppose the rod initially at this position, and after certain time, the rod is at this position. Suppose initially the rod is at this position, after certain time, the rod is at this position. Now, initially object A was at this position, object B was at this position, C is at this position. So after this time, A here, B here, C here. Now, this is the common center, this is the common center. So A rotates in a circular path, like this. A rotates in a circular path like this. About this center, A rotates in a circular path like this. B rotates in a circular path like this. This is the rotation of B. So this is the rotation of C. Therefore, they are moving in three different circular paths. But remember, although they are moving three different circular paths, look at this one. This is the center, this is the initial point, this is the final point. Therefore, theta is equal. Angular displacement is equal in each case. That means angular velocity at each object, angular velocity of each object is equal to the angular velocity of each object is equal. Did you get my point? Angular velocity of each object should be equal, and it should be equal to 10 radian per second. Did you get my point? මේක පැහැදිලි නම් අතුසන I need responses from everybody හැමෝගෙම මම respond එක දෙන්න පුළුවන් නම් වඩා හොඳයි. තේරෙන්නේ නැත්නම් කියන්න. මොකද මේක discussion එකක් විතර ගෙනියන්න. හා. Okay, okay. I will explain. Now suppose there are three circles. with a common center. Now suppose this is the center of the three circle. Three circle has a common center. Now this is the suppose these are two lines. Suppose today this is point A, this is point B, this one is point C. So initially when t equals 0, all the 3 points were at this position. So after certain time, point A is at this position, point B is at this position, point C is at this position. Therefore, the angular displacement of A is equal to theta, and all the three objects create the same angle at the center, same angular displacement. All the objects create the same angular displacement at the center. But their translational distance are change putte. Translation movement is change putte. But what about the angular displacement? Angular displacement is equal. If you consider about this arc length, it is the shortest arc length. This is the next one. This is the highest arc length. Therefore, translational distance traveled by each object varies from object to object. But it is very clear the angular displacement of every object is equal. Angular velocity means angular displacement over time taken. Therefore, angular velocity is equal to angular displacement over time taken. Therefore, as the angular displacement are equal, angular velocity should be equal. Did you get my point? එකක් කරගෙන පොතේ කරගෙන එක ඒ රේඩියස් එක පුරාවට මොකම කරගෙන්නෝ. එහෙම නැත්නම් ඉතින් කරකෙන්නේ දෙයක් නැහැ. Did you get my point? ඒක තේරුණා තුස්සන්? මට හැමෝගෙම රෙස්පොන්ඩ් එකක් දෙන්න පුළුවන් නම් වඩා හොඳයි පුතේ. නැත්නම් මම හරියට තේරුම් ගන්නේ නැහැ නේද? තේරුම් ගත්ත නැද්ද කියලා? Okay, thank you. Therefore, angular velocity of A is 10 inverse minus 1, angular velocity of B 10 inverse minus 1, C is 10 inverse minus 1. All are 10 inverse minus 1. Omega of A 10, omega of B or say 10, omega of C that also 10 radian per second. Therefore, VA means tangential velocity. Tangential velocity is equal R omega, RA omega. Now radius from here to here, radius is 5 meter. 5 meter into omega is 10. That means 50 m is minus 1. 50 response. Then VB is equal RB omega. Radius of B is 10 meter. 10 meter into 10 radian per second. That means 100 ms per second. Then EC is equal RC omega. RC means radius to point C, that is 15 into 10. That means 150 ms per second. Did you get my point? Calculation I need responses from everyone. හැමෝම respond එකක් දෙන්න. Okay, you can write this one. Then the second question, find the translational kinetic energy of 2 kg object. Find the translational kinetic energy of 2 kg object with a constant angular velocity of 10 radian per second in a circular path that has a radius of 0.5 meter. Then do the second question. Taka, second question. Okay, what is the answer? What is the answer? Second question. Second question, what is the answer, Puti? For the second question, what is the answer? Twenty-five. 25 July wakati. Okay. Now you know the object has a the object has a angular velocity of 10 radian per second. 10 radian per second. That means omega is equal 10 radian per second, and radius of the circular path. The radius of the circular path is 0.5 meter. Therefore, you can determine the velocity. You can determine the velocity using this data. Therefore, V is equal R omega. R is 0.5 into 10. That means 5 m minus 1. Then kinetic energy is equal half mv square. This is what translational kinetic energy. Translational kinetic energy is equal half mv square, half m is 2 into 5 square. Therefore, answer is 25 joule. If you got that one, please raise the hand. Okay, then the next physical quantity next physical quantity related to angular motion is period. Period of rotation. Period means it is the time taken. It is a time taken to complete the full circle. Time taken to complete full circle. Time taken to complete a full circle is called a period, Pute, a period. Look at this one. Now there is a circular path. Now here there is an object. Times 2 for 0. So if this object takes capital T time to complete the full circle, if this object takes capital T time to complete the full circle, the period is called as capital T. Therefore, period means time taken to complete a full circle. Time taken to complete a full circle. How to put it? You know, did you get my point? मैं तेरे ना तुझसे मैं explanation में तेरे ना तुझसे time taken to complete a full circle. Right. Then normally we represent the period as capital T. Put it. Normally we represent the period as capital T. And okay, you know, when this object complete a full circle, when this object complete, I need responses from everyone. Have one game answers so make it. අර වාගෙන answers දෙන්න එපා පුතේ හැමෝම respond දෙක කරන්න. එහෙම වුණොත් මම දන්නවා මේ ඔයගොල්ලෝ හැමෝම අහන් ඉන්නවා කියලා අපේ පාඩම. එහෙම නැත්නම් තේරෙන අර පාඩම අහන් ඉන්නේ නැහැ වගේ තේරුනොත් තියෙන මොකක් කම්මැලි හිතනවා වගේ. හරි. ඒ නිසා හැමෝම respond එකක් දෙන්න. Okay. Look at this one. If this object completes a full circle, what is the angular displacement of this object? What is the angular displacement of this object? If this object completes a full circle, what is the angular displacement of this object. I need responses from everyone. I need responses from everyone. I need responses from everyone. What is the angular displacement? Okay. But the angular displacement, how to define angular displacement? How to define it? How did we define angular displacement? आपने कहा angular displacement को define करें? Yes. What is the angular displacement? Angular displacement means the angle subtended at the center of the circle. Center of the circle. Here, when the object moves from here to here, how much the angular displacement? That is equal to 5 radian. Because what time is 2 5 radian? 2 5 not 0. අර මෙතන ගාව නිසා මෙයා displacement එකක් නැහැ කියන්නේ නැහැ. හරි එහෙම කියන්නේ නැහැ. Displacement, angular displacement is defined by the angle. The angular displacement is measured by the angle subtended at the center of the circle. Therefore, angular displacement is equal to the angle of rotation. So, when there's a full circle, theta is equal to 5 radian. Here the angular displacement, You know, according to the definition of period, time taken for one circle is defined as period, capital T. Time taken for one circle is defined as period, capital T. Therefore, time taken is equal to capital T pute. That is period. So you know angular displacement and you know the time taken. If you divide the angular displacement by the time taken, if you divide the angular displacement 2 5 by the time taken, then this is equal to what? Angular displacement over time taken. Angular displacement over time taken. Angular displacement over time taken is equal to මොකද්ද මේ කියන්නේ? Angular displacement එකේ time එකෙන් බෙදුවා මොකක්ද දෙන්නේ අපිට? If you divide angular displacement by time taken, then it is equal to which physical quantity? Yes, angular velocity. It is equal to angular velocity. This is angular displacement by time taken is equal angular velocity omega. So this is very, very important relationship. This relationship is needed for this case as well as it will be needed in unit 3, that means simple harmonic motion. We need this relationship. Therefore, this is very important relationship. 2 phi over t is equal omega. 2 phi means that is the angular displacement per one rotation. T means time taken per one rotation. Time taken per one rotation is called as period. Therefore, 2 phi over period is equal omega. 2 phi over period is equal omega. Alright. So you know V equal R omega, V equal R omega. Therefore, we can subtract omega here, V over R. Therefore, instead of omega, I can replace it by V over R. Therefore, 2 phi over T is equal V over R. Then we can find a relationship between V and period also. Therefore, V is equal 2 phi R over T. 2 phi R over T. Now it is very clear. What is 2 phi R over T? It is very clear. What is 2 phi R? What is 2 phi R? 2 phi R means that is the circumference of the circle. That is circumference of the circle. Circumference divided by time taken. So that is very clear. This is the speed. This is the average speed. 2 phi R means this is the circumference. Circumference of the circle. This is the time taken to complete one circumference. This is the time taken to complete one circumference. Therefore, we can write this one as a velocity, sorry, a speed. We can write this one as a speed. Speed means distance over time, Pute. Distance means that is the travel distance. When the object travels a full circle, travel distance is equal to the circumference of the circle. Travel distance is equal to the circumference of the circle. Therefore, speed is equal distance over time, Pute. Therefore, distance is equal circumference, time is equal the period. Therefore, circumference over the period is equal to the speed. Did you get my point? I need responses from everyone. I need responses from everyone. Damn, one didn't respond to that. Note in your note, you can write this one. This is the circumference. 2 phi R is the circumference. You can write down that in the note. Note means you are tute today. Tute note. This is the circumference. This is the time taken to complete the circumference. Okay. Here are one of the question number, page number 7. Sorry. Please look into page number 7. Page number 7. Find the angular, find the angular velocities corresponding to the following periods. Find the angular velocities corresponding to the following periods. Please do them very quickly. Takka karana. Question number 1 and 2. Question number 1 and 2. Takka karana. Question number 1 and 2. Okay, have finished with it? Have they? What is the answer for question number there are four questions, no? There are four questions. First one, find the angular velocities corresponding to following periods. Angular velocities corresponding to following periods. You know angular velocity is equal to 5 over t. First one, 2 pi over t means 5 over 10. Therefore, answer is 20 radian per second. Answer is 20 radian per second. If you got this answer, please raise the hand. Okay. What is omega, Bute? What is the omega? What is the meaning of omega? Mukad omega again. What is the angular displacement? Sorry, angular velocity. What is the meaning of angular velocity? Angular velocity is equal angular displacement over time. Angular displacement over time. Angular displacement over time. So when any object, when any object completes a full circle, when any object completes a full circle, what is the angular displacement? Angular displacement is equal to 2 pi radian. 2 pi radian, full circle. Like, angular velocity is equal to theta over t. Theta over t, displacement over time. Angular velocity is equal displacement over time. So when any object completes a full circle, the angular displacement is equal to 360. That means 2 pi radian. And according to the definition of period, the time taken to complete full circle, is called as period. Period. Capital P. That is the only thing. This is a simple equation. Omega is equal angular displacement 2 pi. Time taken to complete 2 pi is t. Angular displacement is when there's a full rotation, angular displacement is 2 pi. And time taken to complete full circle is t. Time taken to complete full circle is t. That is the definition of period. Period definition then 4s. Omega is equal to 5 over time. 2 pi means angular displacement of a full circle. T means time taken to complete a full circle. And then 2 5 time taken is 4s. That means 5 over 2 radian per second. 5 over 2 radian per second. That is the second answer. Second answer to son. If you got that answer, please raise the hand. Okay. Then the third one, omega is equal again to 5 over t. Now, here 2 5 t is 5 minutes for the minutes. So you have convert it into seconds. You have to convert it into second. If you convert it into second, you have to multiply it by 60. 60 only multiply. Then omega is equal 1 over 150 radian per second. If you got this answer, please raise the hand. If you got this answer, please raise the hand. Very good. Very good. Then, fourth one, again omega is equal 2 5 over time. Period is 14 minutes. Period is 14 minutes. Therefore, 2 5 over 14 minutes means 14 into 60 seconds. 14 into 60 seconds. That means 30. And I'm going to 5 over 420 radian per second. Then the second question. An object rotates with a constant speed of 10 ms minus 1 in a circular path, and now V is given. That has a radius of 2 meter. 2 meter. Find the period of rotation and the angular speed. Find the period of rotation and the angular speed. Find the period of rotation and the angular speed. Now you are given the speed and the circular path. You are given the radius. As you are given the radius, you know the distance. You know the distance of the full circle. The distance of full circle is equal to its circumference 2 pi r. 2 pi r. So when the object moves a full circle, the distance traveled by it is equal to the radius. And you know time taken is equal to the period, capital T. Therefore, distance over time taken is equal to the speed. Therefore, you are given the speed put there, you are given the radius, then you can determine the time taken. The speed is 10 ms minus 1 is equal to 5 into 2 into t. So t is equal to 5 over 5 seconds. Got it. If you got this answer, please raise the hand. May I ask me got the son? Let me answer again. Yes, it. Sukurma. May I answer again? Okay. Here you are given the speed for this. Speed means distance over time. Distance, if any object is completed, if any object completes a full circle, it will travel a distance which is equal to the circumference. Okay, we will check, okay? Then angular velocity, gradient, sorry, omega. Omega means V over R, no? V over R, V equal R omega. V equal R omega, therefore V over R. Therefore, V means 10, R means 2. Therefore, R is 5 radian per second. 5 radian per second. If you got this one, please raise the hand. You got that, sir? Omega got that, sir? Okay. Then next physical quantity. Next physical quantity is frequency. Here, period. The next one is frequency. What the frequency means, it is the number of rotation per unit time. Number of rotation per unit time is number of full rotation, number of rotations per 1 second. Number of rotations per 1 second. 1 second means unit time. Number of rotations per unit time. Frequency means frequency. Frequency, we call it as simple F. Frequency means that is the number of rotations per unit time. Number of rotations per unit time. And did you get my point? Number of rotations per unit time. Number of rotations per unit time, or we can simply say number of rotations per 1 second. Number of rotations per 1 second is called the frequency. Did you get my explanation? Suppose බලාගන්න හොඳට මම කියන්නේ හොඳට අහගන්න. Suppose the frequency is F. Suppose the frequency is F. So if the frequency is F, if හොඳට අහගන්න මම කියන්නේ if the frequency is simple F, that means there are F number of rotations per 1 second. There are F number of rotations per 1 second. So if there are F number of rotations per 1 second, now tell me what is the angular displacement of this object per 1 second? What is the angular displacement per 1 second? I need answers from everyone. If there are F number of rotations per 1 second, what is the angular displacement per 1 second? What is the angular displacement for 1 second? I need answers from everyone. If there are F number of rotations per 1 second, what would be the angular displacement per 1 second? මෙයාට rotations F ගානක් තියෙනවා තත්පර එක නැත්නම් per second rotations F ගානක් තියෙනවා නම් per second යාගේ angular displacement එක කියමු. Go. I need answers. If there are F number of rotations per 1 second, what would be the angular displacement per 1 second? Right there. That's the answer. Let's do. Very good. Others? Let's do. Subulma? Hmm. Okay. Yes, the answer is correct. Listen to when it. And if there are f number of rotations per 1 second, you know how much the angular displacement, how much the angular displacement per one rotation. एक rotation नेगरे angular displacement ने किया. Angular displacement per one rotation. Per one rotation is equal angular displacement per one rotation. Tackle here. Angular displacement per one rotation. Here. Angular displacement per one rotation. Angular displacement per one rotation. How much? අනිත් පැමට යන්නේ හැමෝගේ මාසරයක් පොඩි. මේකට හැමෝම රෙස්පොන්ඩ් දෙනවා නම් වඩා හොඳයි. මොකද මට මේ කියන්නේ ඒක. බොහොම ලේසියෙන් ගෙනියන්න පුළුවන් වැඩි. කීප දෙනෙක් විතරක් රෙස්පොන්ඩ් කරන්න එපා වුණා කියන්නේ. What is the angular displacement per one rotation? Linet? Nandi? Yasit? Sasidu? What is the angular displacement per one rotation? Angular displacement per one rotation. And I think Mahansi only. Very good. Answers Deepakatti Hari. Yes. Angular displacement per one rotation is equal to 5 radian. 2 5 with a one rotation act like a full rotation. If there's a full rotation, the angular displacement is 2 5. 2 5 radian. If you get this one, please raise the hand. If you got this one, please raise the hand. Make it not to son. I don't want to Angular displacement per one rotation is 2 5 radian. Therefore, on one rotation, angular displacement per one rotation is 2 5 radian. Now there are how many rotations? Now there are f number of rotations per 1 second. F number of rotations per 1 second. Angular displacement per one rotation is 2f. One rotation. If rotation not put 2f. So if there are two rotation, 2f into 2. If there are three rotation, 2f into 3. If there are four rotation, 2f into 4. So if there are f number of rotation, angular displacement per f rotations should be equal to 5 f radian. 2 or 5 f radian. Did you get my point? Angular displacement per f rotation. Now you know there are f number of rotations per 1 second. Therefore, this much of angular displacement is done per 1 second. Per 1 second. Therefore, angular displacement per 1 second should be equal to this one. 2 5 f radian. If you got this one, please raise the hand. Angular displacement per 1 second is equal 25 radian. There are F number of rotations per 1 second. There are F number of rotations per 1 second. So if there are F number of rotations, angular displacement is equal to phi F. That means there are 2 phi F radians per 1 second. You know, angular displacement per 1 second. Angular displacement per 1 second means angular velocity. Angular displacement per 1 second. Angular displacement per 1 second is equal angular velocity. Okay. Angular velocity, omega. Therefore, omega is equal to 5 F to 5. Omega is equal to 5F. Is that clear? If you got this one, please raise the hand. Okay. So this is the relation between angular velocity and angular displacement, sorry, frequency. Angular velocity and the frequency. You know, there's a relationship between angular velocity and the period is 2 phi over t, and this is equal to 5f, 2 phi f, 2 phi f. This is equal to 5. Omega is equal to 2 phi over t and 2 phi f. Now it is very clear f is equal 1 over t. F is equal 1 over t. Therefore, frequency is equal 1 over period. Frequency is equal 1 over period. Frequency is equal 1 over period. Is that clear? If you get this one, please raise the hand if you want to some. And the theory. In angular motion, no, you know, I think you have this knowledge in your orders. You know, V equal F lambda equation. In you did some part of waves in orders, okay? Therefore, at that time, I think you learned the unit of frequency. What is the unit of frequency? What is the unit of frequency? Look at the frequency unit. Yes, hertz. Hertz. Yes. Yes, if it is a wave, we know the unit of frequency is hertz. Okay, normally we call it as hertz, but here generally we do not use hertz as a frequency of a rotational motion or circular motion, and that is a general practice. Okay, general practice, that is, there is no any rule, but it's a general practice. Normally, we do not use hertz as the unit of frequency. In rotational and circular motion. That means in angular motion. In angular motion, normally we do not use that thing. Instead of that unit, we are going to use some specific unit. One is You know, this is time of f. This is time. This is time. Therefore, unit of f. First unit is per second. First unit is per second. Because you know, this one is equal to second. Therefore, unit of frequency in angular motion is per second. Per second. Or otherwise, there are some special unit to represent f putih, that is revolution per minute or revolutions per seconds putih. RPM or RPS, revolutions per minute or revolutions per second. Revolutions means rotation of full circle, rotations of full circle per minute, rotations of full circles per second. So that is another way of representation of frequency. Therefore, frequency can be represented by RPS and RPM. මම හිතන්නේ ඔයගොල්ලෝ අහලා ඇතිනේ සාමාන්‍ය ඔය vehicles වල ඊට පස්සේ ඔය measure equipments වල ඔය rotational parts තියෙනවා නම් RPM එක එහෙම අහලා ඇතිනේ. අපිට සාමාන්‍ය dashboard එකේ තියෙන RPM නේද? dashboard එකේ තියෙනවා අපි දැන් vehicle එකක් ගත්තොත් එහෙම එයාගේ මොනවද මේ ඒ රෝදේ කරකෙන RPM value එක තියෙනවා. wheel එක කරගෙන RPM value එක කියලා තියෙනවා. ඒ මොකක්ද? number of full circle, number of full rotations per minute. මිනිත්තුවකට කොච්චර full rotations කරනවද අන්න එක තමයි RPM value කියලා කියන්නේ. එතකොට ඔයා දන්නවනම් wheel එකේ radius එක, then you can determine the distance that can be traveled within that period. Okay. Therefore, RPM and RPS means there is another way of representation of frequency, represent the frequency. RPM means revolutions per minute. This is revolution per second. Revolutions per second. Did you get my point? Okay. Hi. Then we can take a small break. Okay. Now we can take a small break. So after this break, we will do some questions. Then we will start the most important lesson in circular motion, that is angular acceleration. Angular acceleration. හොඳටම තේරුම් ගන්න ඕනේ ලෙසන් එකක් angular acceleration එක angular accelerations කොහොමද ඉන්නේ කියන දේ ඒවා directions ඒවා magnitude ගන්න විදිය ඒක ටිකක් කතන්දරයක් තියෙන තැන හොඳටම තේරුම් ගන්න ඕනේ තමයි. හරිද? ඒ නිසා refresh වෙලා ඉන්න නිදිමතන පොඩ්ඩක් උඩ බලලා හරි පොඩ්ඩක් නිදිමත අරගෙන එන්න. හරි. Okay. Then you can take a break. We can start the next session at 9:30 p.m. today. So take a break. Okay, with it. Can you hear me? Herhalde. Shall we start? Okay. Shall we start? Herhalde product. Tambeta. Okay. We can start with it. Okay. Uh, Actually, we was discussing about frequency. As we discuss about uh, the frequency, there are three basic units that can be used to measure frequency. One is per second. Other one is revolutions per second. Other revolution per second and revolution per minute. That means RPS and RPM. So RPS and RPM, those are the most common units of frequency. Revolutions per second per minute per minute. So suppose if there are 10 revolutions per second, if there are 10 revolutions per second, that means per second there are 10 revolutions per day. So if there are 10 revolutions per second, what is the number of revolutions per minute per day? If the rate is constant, what would be the revolutions per minute? 10 revolutions here. If there are 10 revolutions per second, how much revolutions what would be the number of revolutions per minute? Per minute revolutions here theorem. Yeah. Yes. No six there. At end of the area. Per 1 second, there are 60 revolutions to it. Per 1 second. Therefore, if you consider 2 seconds, then there are 2 times of that. If you consider 4 seconds, there are 4 times of that. Therefore, if you consider about 60 seconds, 60 seconds means 1 minute 60 seconds, then definitely there should be 60 into 10 revolutions. Therefore, per 1 minute, there are 600 revolutions. Therefore, we can convert RPS into RPM using this conversion method. Therefore, if you are given a value, in RPS, you can multiply it by 60. If you multiply it by 60, then it will be converted to RPM. It will be converted into RPM. Yeah. Per second, if there are 10 revolutions per 1 second, then you can multiply both sides by 60. Then 60 seconds, there are 600 revolution. 60 seconds means 1 minute. 1 minute for 600 revolution. That means If you are given the frequency, if you are given the frequency by RPS, you can multiply it by 60 to convert it into 6 RPM. Did you get my point? I had it. Oh. Doesn't happen. Then the other way, if you are given the frequency, if you are given the frequency by RPM, you can divide it by 60 to get the value in RPS, to get the value in RPS. So this is the conversion of RPM to RPS, RPM to RPS. And then how to convert this into a omega? Omega means angular velocity. So if you are given 60 revolution per second, write this question. This question. Thank you. If you are given 60 revolutions per second, what is the, sorry, if the frequency is 60 revolutions per second, it's 60 RPS. If the frequency is 60 RPS, what is the angular velocity and period of the circular motion? If the frequency is 60 RPS, what is the angular velocity and period of the circular motion? Remember, now frequency is equal 60 RPS. 60 RPS, put it. 60 RPS. 60 RPS means there are 60 revolutions per 1 second. 60 revolutions per 1 second. So you know 60 revolutions per 1 second of omega means 2 phi f. Therefore, 60 revolutions per 1 second means 2 phi into frequency 60 revolutions. If there's only one revolution, then angle is 2 phi. Now there are 60 revolutions, that means 2 phi into 60. That is the angle. So this angle per 1 second. This angle is per 1 second. Therefore, angular displacement is 125 radian per 1 second. தெரியும் எனக்கு தெரியுமா புதுசா? Okay. Uday, then you can take the tube number 1. Mandara Goladi group Dadi tube 1. Please look into the tube. Please look into the tweet which was sent to the group. This is all home assignment number one. Assignment number one. Quickly do the question number 4, 5, and 6. 4, 5, and 6. Tackle करो 4, 5, and 6. Tackle करो. Pori garanti का तीर नहीं garanti का तीर नो pori garanti का. Quickly do the question number 4, 5, and 6. Convert the following RPM value into RPS. Sorry, radian per second. Radian per second. That means we need to determine angular velocity. Okay, Putri. Look at the question number 5. Sorry, question number, yes, 4. Question number 4. First one. You have to convert them into radian per second. That means you have to convert them into omega. So you are given RPM, not RPS. You are given RPM. Therefore, omega is equal to 5. 5. F means 2/5. This is RPM. This is RPM. 2/5 is RPM. This should be divided by 60 to convert RPS. Divided by 60. Now, this is for revolution per second. This is radian. Therefore, radian per second. Therefore, 1/15 radian per second. If you got this one, please raise the hand. Venga, ahora Susana. No. Then the second one. Pi was 5/5. Therefore, 2/5f, that is equal 2/5 into 5/5. This is a radian per minute. Put a radian per minute. To convert it into radian per second, you have to divide it by 60. Therefore, 5 to 5 will be cancelled out. As is 1/6 radian per second. Okay, if you got this one, please raise the hand. Then the third one. Twenty-seven. Therefore, 2/5f is equal to 527 revolutions per minute. Therefore, to convert this one into revolution per second, it means you have divided by 60. Para 9/5/10 radian per second. If you got this one, please raise the hand. 9/5/10. Legal? Okay, the third one. The fourth one. 30/75. 30/75. Two 5f is equal to 5 into 30/75. 30/75. This is in radian per minute. So to radian per second. Therefore, 5 to 5 will be cancelled out. Therefore, answer is 1/7 radian per second. 1/7 radian per second. If you got that answer, please raise the answer hand. No. Have. ඊළඟට fifth one, convert the following radian per second into RPM. Now you are given omegas. Then you have to convert it into RPM. Now fifth one කරන්න නැති ඔයාලා කොහොමද 4-5 radian per second. You have to convert 4-5 radian per second into RPM. Therefore, you know the relationship between omega and frequency. Now you need to determine frequency. Frequency is omega out to 5. Now you are given omega per second. Therefore, four 5 over 2/5. This is per second. Okay, this is per second. Therefore, per minute, you have to multiply it by 60. Make it right there. 2. The fast is 120 RPM. 120 RPM. If you got this one, please raise that may answer Gatran Tusa. Anita calculator. Then 4/5. Sorry, 24/5. Second one. Second one. F is equal omega over 2/5. Omega is equal 24/5. 24/5. Twenty-four 5 4 2 4. මේ per second තියෙන්නේ therefore for minute කරන්න මේක system එකේ කරනවා. 5 will be cancelled out here into 12 into 60. 12 into 60. Very important. Okay. Then third one. Seven over two. Now omega is equal to 5f. That means frequency is equal omega over 2/5. Okay. Omega is given 7 over 2. 7 over 2. 1025. This is radian per second. This is radian per second. So you have to convert it into RPM. Then you have to multiply it by 60. If you got this fellow, please raise the hand. If you got this fellow, please raise the hand. Letter 25 5 over 3. Twenty-five 5 over 3. Two five, yeah. Correct. Omega is equal to 5 over. Then 25, sorry, sorry. Now F is equal omega over 2 5. Omega over 2 5. Omega is given 25 5 over 3. This is radian per second, no? This is radian per second. Radian per minute, revolution per minute should be 60 times than this. We're gonna make the gain. Therefore, 250 revolutions per minute. Revolutions per minute. If you got this one, please raise the hand. There are those one. Correct. Then the question number 6 one, question number 6. Convert 50 revolutions into radian. Convert 50 revolutions into radian. 50 revolutions. 50 revolutions means there are 50 circles with the 50 circles. No, 50 revolutions into radian. There are 50 circles. Full circles. 50 revolutions per 1. 50 revolutions per revolutions into radian. That means one revolution is 25 radian with it. One revolution is 25 radian. 50 revolution means you have to multiply both sides by 50. Therefore, omega is equal 105 radian. Is that clear? May I tell now? If it is clear, please raise that. If it is clear, please raise the hand. Everyone push up. Okay. B. Convert 48 radian into revolution. 48 radians into revolutions. 48 revolutions means 48 into 25 radian. Correct. Forty-eight revolutions. Sorry, 48 R80 only. 48 5 R80. 48 5 R80. 48 5 radian. Should be converted into radian per square. So radian per. Sorry, radian. So now this is the amount of revolution. This should be converted into radian. 48.5. Hadi putih. Hadi putih. Now 48.5 radian should be converted into RPM. Okay. Now it is very clear. So this is omega means revolutions per 1 second. Revolutions per 1 second. Therefore, there are full revolutions per 1 second. So it is equal to 16, the 40. We're find now. Negative 24 radian. Hello. Do you have any questions regarding this? Sorry for this. Sorry. This is not omega or if this is just revolutions over 2 5. Revolutions over 2 5. Now, sorry, omega of f mean. Now you are given revolutions. You are given actually this is you are given revolutions. You are given number of revolutions. You are given number of revolutions. So if you divide number of revolutions by 2 5, then you will have the radian. How to get that from? How to get that conversion? You can just one revolution. One revolution. Sorry. But sorry, I got that. With a one revolution equal to 2 5 radian. One revolution is equal to 5 radian. Well, therefore, if you convert this into 1 radian is equal 1 over 2 5 revolutions. Now you are given 48 radius. 48 radius, that means both sides should be multiplied by 48. 5. 48 5. Therefore, 48 5 radian is equal 1 over 2 5 8 to 48 5 revolutions. And F1 वगैरह angle actually में one revolution is equal to 5 होते, therefore 1 radian is equal 1 over 2 5 revolutions. Then 48 radius means you have to multiply both sides by 40. Then 48 radian is equal 1 over 2 5 over 48. And again, therefore 24 revolutions. Make it clear. Did you get my point? If you get my point, please raise the hand. Raise your option. All right. Do you have any questions regarding today's session? question මොකද accelerations පටන් ගත්තොත් ඒ පටන් ගන්න වෙලාවක් නැහැ ටිකක් ලොකු පාඩමක් දැන් කතා කරොත් අපිට ඉවර කරගන්න බැරි වෙනවා. එහෙනම් ඒවා angular acceleration will be discussing next class, but that means Tuesday's class. So you have to go through the lesson. Then angular accelerations and type of circular motions will be discussed in our next class. So tell me up to now, do you have any questionable area? Do you have any questionable area up to now? The questionable area का? Thank you. Thank you, Putri. Okay. Then we can complete today's class. Then Tuesday's class. If I can start to this, we start Tuesday's class a little bit early. I will let you know. But if not, it will be start at the regular time, Putri. Then in Tuesday's class, we will discuss the rest of the circular motions part. Then next Sunday's class also. As I discussed you earlier, Putri, after completion of this part, we will do fluid mechanics in our Sunday class, and Tuesday class we will start waves. Okay. For both parts, I will send you a note. I will send you the note. And okay. Anyway, we can complete today's class, Putri. Then everyone, good night. Putri. You're welcome, Putri. You're welcome. You're welcome. You're welcome, Putri.